Thank you for coming. So yeah, this is going to be a very interesting talk because this is my first time giving this talk. And so before I start, I think this is the most important slide because it has a link. Well, it's not very clear right now. I'm so sorry. I just added in last minute because I forgot. But anyway, there's the link at the bottom of it, which is the link to this slide deck. It's live in slides.com. You can, if you can't see the link, you just look me up there. You may be able to find it. So also, that's my Twitter handle. I'm still on Twitter. I may not in the future, I don't know, but you can still find me on Twitter while I'm still there. And of course, take pictures of me, post it online. I love publicity. Thank you so much for that. And also, you're very welcome to, if you just come and sit down. I've just started. You haven't missed anything yet. So, no GIL, okay, it's fun. But before I start, maybe I just want to know a little bit more about you. How many of you know what is a GIL? Ooh, okay. Oh, wow, it's very good audience that people already have some idea about what I'm going to talk about today. But I'm going to also talk a little bit about the GIL, just in case if you haven't heard about it, it's fine. I would make sure everybody's on the same page. Before I really start, I'm Cheuk and I work for Anaconda, so I'm really passionate about this scientific programming and all stuff to help people who are working in data, working in data science, help them to get their job done better. So also if you have any kind of questions or feedback about things that Anaconda get involved in, talk to me. Maybe I can point you to the right person to talk to them. Also, I love open source projects. I work in a lot of open source projects in the past, so including those. You may not know what they are, but it's fine. Also, I organize events. So in the past years, I've helped organize different conferences and different local meetup events. Also, I will have an online conference coming up at the end of this month, so I will talk a little bit about it later. So that's enough about me. What is a GIL? So for those of you who doesn't know, GIL actually is, well, basically it's a combination of three letters, right? So it means it's a global interpreter log. So it still doesn't make a lot of sense. So what this log is for? Why is it global, right? The idea is that we want only one single operating system thread to run Python. The reason being that if you have multiple threads accessing the same object, it could be very tricky. For example, in Python, we know that there are some mutable objects, right, like list or dictionary. So if there's more than one thread trying to access that thing, so funny thing may happen. For example, one thread is reading something, but the other thread is trying to change it. So there's a clash, and we don't want that to happen. So a lot of different programs would try to solve that problem with many different logs. They just pass the ownership, when different threads are working together, right? They have to release them, they have to log them to make sure that this clash doesn't happen. But for Python, the simple solution to solve this problem is that when you're running Python, there's a global log that basically only one thread can run Python, right? So there's no clash ever. It's very easy to implement that, but there's some limitation. So that's why people are talking about no GIL for a long time. That is it possible that we can actually make Python to do use multiple cores to have multiple threads to run code, so it's much faster. So basically, if you want that, you have to get rid of the GIL. So we talk about no GIL. So a no GIL Python, what is this? So this is something that I know about it in the past, in this year, actually early this year, I know about it. It's actually a clone of the Python 3.9. So now since we are already in Python 3.11, it sounds a little bit old, isn't it? But it's fine. It's actually the fourth attempt to get rid of the GIL. Their previous very genius, very brilliant engineers tried to do that. And there are different attempts, so you can look it up if you want to know what they did. But I'm going to focus on this this attempt to remove the GIL. And this attempt is by Sam Gross himself. So he has been given a talk in EuroPython earlier this year. And that's why I was like very fascinated and interested about this project that he's working on. So, yeah, like I said before, because Python now, with the GIL, with the global interpreted log, there's only one thread can run Python. So basically, if you run a Python, let's say just like vanilla Python without any extension, you run it on a single core computer, and a multi-core computer basically is the same, right? You can only use one thread to run Python. So we want to make use of the multiple core because a lot of computers nowadays will have, my computer is old, but it's still dual core. So nowadays you can get things that's like, quad core, that's, common right now. And if you are doing something, if you are working in university, you may have access to a more powerful machine and have multiple core. Or sometimes you have these, that it's not sitting on your desk. You have somewhere that you can connect to, and they have supercomputer that have many, many cores. So we want the speed. That's why, this is something that people keep trying to do. So a little bit about this design of this no-GIL version of Python. First of all, the first thing that Sam mentioned is that it needs to be good on both single thread and multi-thread because there will still be some programs that actually still kind of not compatible with, no-GIL or multi-thread and all this stuff. So we can't sacrifice them, right? We can't sacrifice and let them be slow by, but it's only good on certain machine and things like that. So it can't be like this. Another thing is why this no-GIL thing is so difficult. This is the fourth attempt, right? Why people keep trying it and why there's no solution, no definite solution of it yet. It's because it's difficult. This reference counting is one of the things that's very difficult because, when we run some program, we would try to, have objects that are created and they can be accessed by some reference. But, if you have multi-thread, that keeping track of how many objects are created or this reference can be quite tricky. And if we mess up in this step of reference counting, we will have memory that is lost in the abyss, right? They are occupied, but we don't know, we can't access them anymore, and we don't know we're not using them anymore, so they'll just be floating in the abyss. So we don't want that to happen. So reference counting becomes very tricky when we don't have the GIL. And I won't dive into all these deep dive into all these technical details. You can watch his talk if you want to. The recording is now on YouTube. But basically, how he solved this problem is using something called bias reference counting. Also another trick that he used is to make some commonly used object immortal. For example, in Python, there are some objects that basically whenever you're using it, it's referencing to the same thing. For example, true and false and none, these objects are, there, and you're not creating a new one. And for example, some small numbers, they are already there. When you run Python, it's already created, and they are there for the rest of the runtime of your Python. So for those objects, he said that there's a trick of not using a reference count for them, and it's very funky. So for these objects, right, you don't count them, but you have to deal with them when you're kind of doing the garbage collection. So you have to, so it's deferred. So you have to add, sorry, let me backtrack a little bit. So some of the objects that is globally accessible. So those objects are actually using the defer reference counting, which means that they only get dealt with at the when you do garbage collection. So they are actually hanging there all the time until it's at the end that it's not needed anymore. So the counts are adding back to the reference counting. There's a lot of interesting things that he did. I want to inspire you to check out his talk. And also there's other thing that having no GIL will have, this problem is that, for example, the thread safety, again, the GIL is there to lock that no thread's going to be accessing the same object at the same time and create that clash. So we need to make sure that this, this is handled, like we won't have the clash even if we remove the GIL. So you now have to do what other programs doing, right? We can't just use the global interpreted lock. We have to use smaller locks to hand things over, like who is doing what right now. So you have to orchestrate this complicated stuff. And in his talk, he showed that actually you can do that by, having like, because when you have, when you're writing Python code, you just type Python, right? But when Python is interpreting your code, actually there's, in C Python, there's a lot of like different instructions to call the C API that is running some C code. So in that, now you have to have some specific C code that deal with when you pass the lock over, right? When are you locking it, when are you unlocking it? So you have to add those in. So there's a lot of work is done on the C Python level of things. Also, the one thing that he mentioned is that now Python is using a Pyjamas log to handle the thread safety. And basically, he said that now we'll replace it with something else. It's like numerical. Again, I won't dive into the detail. If you want, you have to check out the online resources, which I'll post at the end. So this is a new log that is written by a team in Facebook, or Meta, maybe it's Meta right now. So, so they created this new log that works different from what Python is doing right now. So this is another big surgery to the C Python code that is done to get rid of the GIL. And also now during the garbage collection, which is a very, very delicate process that, again, if you mess up at this process, there will be some memory that got lost in the abyss, and we don't want that to happen. So it's very important. That's why, like, when you don't have the GIL, you have to stop the world for the garbage collection, meaning that, like, when you collect the garbage, there's no all this like hand over the log and all this stuff. Like, no, you can't do this because this will mess up the garbage collecting process. So you have to stop the world for it, which is something that you think like, oh wow, you have to stop everything, and you can't do that. So it sounds really, really complicated, and it kind of took me some time to understand what it is. But what I care about, again, like I really care about scientific calculation and all this, like people using a lot of data and data science and all this stuff. So how does it perform? Like, does it improve it or does it not improve it? So I have a few questions actually after that. So this is the part that I really want to understand whether that would help with my job or other data scientists or scientists' job, right? So I have a few questions because a lot of scientific packages is using a lot of different methods to speed up. And they have used a lot of actually plugins, like a lot of C code, a lot of CPy modules. For example, if you are using NumPy, so who has looked at the source code of NumPy before? Some, yeah, not many people, but well, why would you look at the source code of NumPy? So, but if you're interested, you look at the source code of NumPy, you see there's a lot of CPy modules in there. So what are those things? Those things are actually the plugins. They are actually C code. They're written in C code, but they are actually written in a way that it can talk with your Python code. So it will basically, the idea is to speed up because those files are written in C, so they are faster than writing it in vanilla Python. And also there's another package that's called Siphon. I don't know whether you have heard about Siphon. Siphon is, again, another tool that kind of, you can have a function and use Siphon to kind of compile a certain function and then make it into C code and make it faster. It's kind of like the CPy module, but instead of writing it yourself, Siphon will generate that for you. And in Siphon, you can already use nogil, kind of. So how does it help, right? So I'm kind of like having the question. So also, does the program benefit from nogil? It's like, will my code be faster? That's the ultimate question, right? Like, why do I care about all this complicated stuff? All I want is my code to run faster. Will it run faster? Is it true that I can get faster if I use nogil? So I'm going to test it on some processes, right? Like, so I'm going to get my hands dirty and do some testing myself. I did something. I want to try on something that's with scikit-learn, numpy, and scipy, those things that we do a lot when we do scientific programming. Or maybe something about neural network, but at the end, I don't get to try it on TensorFlow or PyTorch because those need to be compiled specifically for the nogil version, which is more complicated. So at the end, I decided to just stick with scikit-learn and numpy, which the nogil version is already available, so it's much easier for me to test things out. And my method is not very scientific. I'm criticizing myself right now, so please take my result with a grain of salt. I would also have all the code that I tried put on GitHub, so if you want to try it yourself, you can do it. So the following, what I'm going to do is to compare 3 versions of Python. One is the nogil version. Remember, it's a clone of 3.9. It's just that Sam have tons of work on it, which is amazing, to remove the GIL, right? And I want to test it on the 3.11, which is the newest version of Python, because 3.11 say that they are, like 10% faster than 3.10. So 3.10 is also faster than 3.9, so supposedly it should be faster than 3.9, right? So I'm going to test it on them. So yeah, the code are on GitHub, so if you grab the slides, you can click on the link and find it on GitHub, and you can play around it yourself with your computer, maybe. So first test, I'm doing the SVM. So SVM is support vector machine. It's it's a process that we use a lot in scikit-learn. So I'm just using an example on the scikit-learn website because it's the typical things that you do, right? So you can find that example on the scikit-learn website as well. So I'm calculating it, and I average over 50 times because when I try it, I realized that actually there are some deviation in different runs. So I just run it 50 times and divide it by 50, right? and that's how I do it. So this is the result. As you can see, there isn't much difference. So they're already very fast, but there's not really a difference between all of them, right? So okay, and the next thing that I try is clustering. So clustering is very interesting because in scikit-learn, the example there, again, I average over 50 times, but they use different algorithm to do it. So there's k-mean, or you can use a PCA or random to do the clustering. So how do I describe clustering? It's like you have a lot of data points and you want to group them into different groups in multiple dimensions, right? So again, there's no significant difference. So now I'm really scratching my head, right? So even 3.11 is not that much faster than 3.9. I was like, why? But by the way, I run it on my this computer, which is a dual core, but it's like a 2015 model, I believe. It's very old. So try it with your computer if you want to. It may be better. Decision tree. Decision tree is a process that basically, you kind of separate the data, trying to find a way to separate the data so you can judge what something belongs to a certain category by that. And so it requires a lot of repetition for this algorithm, actually. So actually, 3.9 is the fastest here. I'm like really puzzled. It's like, why? It's not fast by a lot, but it's slightly faster than the others. Okay, let's move on. And now I try on NumPy. So NumPy, we have some linear algebra. So this is a ND array. So ND array is just like a multi-dimensional array. And I try different algorithms on it. They're like SVD, norm, transpose. It's just mathematical algorithms. I won't talk into detail, but you can find all of them in the link. So a link to the demo there. And 3.11 is actually the fastest this time, and then nogil, and then a 3.9. So, okay, so we see improvement here, but mostly 3.11 is faster. And the last thing is, this is very interesting. This is, this is not the last thing, but this is the the image filter. I think I tried one more later. Yeah, I tried one more later. But this is okay. This is the image filtering. So image filtering is you can actually put an image into a NumPy array, right? So in a NumPy array, you can apply these different filters on it. So it's like well, if you do a Photoshop and then you can apply filters for your photos, right? So this is similar, but you do it with NumPy. So there's some mathematical equations to apply this filter. So among all of them, so nogil is actually faster with the Gaussian ones. There are variants of those. But for the others, actually 3.9 and 3.11 are faster. So there's really no obvious winner here. And the last one I tried is a little bit of MLP, which is multi-layer perceptrons. So it's kind of like machine learning, deep learning kind of thing. With it's like multi-layer perceptron. I don't know how to explain it more. So this one again, 3.9 is the fastest. So it's not really showing improvement by all this effort. So I'm frustrated. Does it mean that nogil does not help? Does it mean that all this effort doesn't help with scientific programming? Are we losing out, right? If you're doing scientific programming, I can't benefit from this. So I kind of have to think why we didn't see any difference or any improvement on this data, because this is not what I'm expecting, right? I'm expecting improvement. So I think there's a few reasons. Well, again, because all these libraries are already using a lot of C extension and a lot of process that may already make use of removing the GIL for certain computational heavy process in certain part of their calculation. All this C extension or this Python is already doing that. So when we just kind of blindly apply different versions of Python on it, we may not see any improvement because of that. Also, there's another thing that people raise questions about is that, maybe the C extension is not expecting the Python to be nogil, right? Because when this extension is written, is kind of assuming that you're running it on a C Python version, which is, having the GIL. So that may not, that may not help. Also, we need to think that whether we can kind of having the improvement passing over by having adoption into the no-GIL mode. Maybe we need some kind of C API when Python is talking to C and C is talking to Python. We have to adopt this no-GIL mode on the Python side. And compatibility again, maybe because it's designed not for no-GIL Python, it's for normal Python. Also, my computer may be a problem, right? I'm only having a dual core, so if there's a slight improvement, I may not see it that much, because when you run it on multi-core, there's always, multi-thread, you always have an overhead, right? For example, like this thing I said, you have to pass over the smaller log and stuff. So those are the overheads that is added once you go to the no-GIL mode. And because I'm only having a dual core, I'm not comparing one core to 8 core, so the speed up doesn't really show the benefits because of the overhead. And also, this no-GIL Python is still in progress. I don't know. I'm not involved in the C Python core development. I don't know what their plans are, but it seems like from what they have talked publicly, the no-GIL version is not going to integrate into the C Python yet, and there's no plan for it yet. So there's still a long way to go. So I don't know. What's your opinion about it? I don't have any insight about it for you. So I think that's come to the end of this talk and this experiment and discussion. So most of the information I got is from these two. I already mentioned the keynote by Sam at EuroPython is great. Watch it again. It's on YouTube. It's just released, actually. So please check it out. Also, amazing, EuroPython talk. All of them are available on the YouTube. So please check it out. Also, there's a very amazing blog post by Lukasz. It's he mentioned about this in his blog post when Sam and all the C Python developers are having discussions. So very good, like a lot of information there. Check that out. At the end, I want to highly recommend you to register for Pyjamas Conf. It's at the end of this month. It's free. You can just get a ticket for free, and it's online, so you can watch it at the comfort of your home. So I think that's the end of my talk now. So thank you so much for listening to me, and I will see you in the social event maybe. Yeah.
Thank you. We have a couple of questions. So the first one, does Anaconda look into the no-GIL efforts?
Yeah, so this is actually my personal passion about this like speeding up thing. So so far we not I can't say that like officially that Anaconda is like doing anything about it. No, we haven't. But it's just something that I'm very interested in myself. Yeah.
Okay. Does no-GIL get updates when normal Python comes out?
Sorry?
Does no-GIL implementation get updates where regular Python comes out?
Oh, you mean like now it's the clone of 3.9,
Yeah.
where it'd be like 3.11. So again, it go back to the conversation of like, it need a rebase, right? Like for example, if you want to send a PR to, let's say, NumPy, you have to rebase it to keep it up to date before you can merge it. So again, because there's like, so far there's no plan of merging the no-GIL into so far it's still a clone of 3.9. But for details, I guess you need to ask Sam yourself. I don't know. So yeah.
So somebody asks if you can share that repository with those experiments.
The experiments. Yeah. Oh yeah, the code actually is on GitHub, but the link is on the slide. So if you go to this slide, which the link is here, you can go to the slides that I talk about, or the code, and then you click on the link there, then you can go there. So you can run it yourself. It's just all the examples that I get from all these documentation sites and modified it to time it myself, yeah.
So there's a question if you try that with libraries that don't have multi-threading under the hood.
Yeah, that's a very, very good. I think they have, obviously, Sam himself has done some benchmark on, I think he has done it on Fibonacci function. So I haven't tried it extensively on other library except like mostly scikit-learn and NumPy. But yeah, I think, for example, something that I may, I don't have time, I want to try is like, for example, fuzzy wuzzy, which is using the Loewenstein's distance to like calculate the difference between two strings. Those are very computational heavy, but it's not it's not speed up by NumPy. So yeah, that's something that's good to try. I may try that in the future. So yeah.
Do you think that no-GIL, we will see no-GIL in Python in even a few years? It would break most of the extensions and require a lot of work from core devs.
Yeah, I think that's also a concern. Like when you look at Lucas' blog, he talked about when the C Python developers are discussing this, one of the concerns they have is the compatibility issues, right? So they have concern about it. So I guess if it happens, that it will be already taken care of. I guess I just trust them.
All right, I guess that's. Thank you.
Thank you.